Welcome back to Designing Compute Solutions. In this lesson, we're going to be talking about determining compute options for microservices. So first off, what is a microservice? Applications are composed of small modules which you communicate using, standard API contracts, right? So a module may be designed to send out a communication, another may do a data call, another may scan a storage block for capacity, things like that. Basically, all these little functions that you can put together and create with a larger purpose, right? So they're little programming Legos. And for compute design, of course, you're going to want your environment to support the sort of operations that your microservices are going to be built to do. There are two primary approaches when putting together compute for microservices. You're going to be looking at serverless or using a service orchestrator. Now, the serverless approach is basically Azure Functions. You deploy your code, and Azure Functions will dump that into a VM to execute. Some options include service bus queues, event hub, events, and message processing. Service orchestrators are basically Kubernetes and Service Fabric. Kubernetes can be sort of thought of as Kubernetes APIs as a service, except limited to use in containers. Service Fabric can package, deploy, and manage microservice, and it can also run processes as binary executables. So when looking at containers to run microservices, here are a few things you'll want to keep in mind. I'll definitely, to start with, containers are not the same in and of themselves as microservices, and a container isn't necessarily required to run microservices. So Service Fabric does not absolutely demand that a container exist in order to do its job. And of course, functions don't require containers at all. But when looking at containers, there are a few things that make them quite useful. One, portability. Images are considered standalone packages without any libraries or dependencies, and it makes them easy to deploy. So you can have a nice, reliable structure, and that structure can be easily repeated over and over again. Next is density. Containers are very lightweight compared to running full VMs. As you know, containers share operating system resources, so there's a lot of overhead there that you don't have to establish by running individual VMs. And then there's also resource isolation, because you can build a structure around the container in terms of CPU and memory. You can prevent anything that's running in that container from taking down your entire system. So if you're running on a VM and you get a runaway process, that can cripple the whole VM. Whereas in a container, it will only be that single process that gets broken. Looking at serverless, you can get away without having to manage any VMs or any virtual network infrastructure. So there's a lot less work in terms of preparation to set up functions. And your triggers for functions can include HTTP, blob storage, event hub, events, Azure Queue, and service bus queues. So when you want to choose between an orchestrator or a serverless approach, here's a few things to keep in mind. Manageability. In serverless structures, the platform manages all the compute resources. You really don't need to think about anything other than setting your microservices off, or your functions to run as needed. And beyond that, no overthinking is required. Using a service orchestrator, then you're going to, of course, have to deal with load balancing, CPU and memory usage, and the networking infrastructure. Using an orchestrator, you get a lot of control over the configuration and management of your services and the Kubernetes cluster. That could be quite useful if you're wanting that level of control. In a serverless environment, you get a lot less control because a lot of the details are simply run by Azure. So it's a question of, does the level of control for an orchestrator serve your uses, or are you better off with just running serverless? All of your orchestrators, be they Kubernetes, distributed cloud, Docker Swarm, or Service Fabric can run on-prem or in multiple public clouds. Serverless, of course, does not allow that. You can strictly run it in the cloud, and that's it. In a serverless architecture, you can find that keeping all of the applications together and working in tandem can be difficult. So logic apps are able to help coordinate those sets of functions. Orchestrators, of course, don't have that built-in capability. And, of course, with orchestrators, you pay for the VMs in the cluster, and that's full price for them. For every compute minute they run, you get billed. In the serverless environment, you only pay for compute resources that are consumed when they are consumed. Now, in both of these cases, you have to remember that there are other services in play besides simple compute. So storage, database services, messaging services, that sort of thing, ingress and egress data. So be aware that it isn't just compute costs that you're going to be saving or spending more of, depending on which approach you take. And then the last thing we're looking at is, of course, scalability. Azure Functions will scale automatically. So as more compute is required, the Azure will simply ramp it up for you in the background, and you'll never even notice it functioning slow or faster than it ever does. It'll be the same speed all the time. In an orchestrator environment, you increase your scale by increasing the number of the service instances in your cluster, or you can simply add more VMs. This is something you have to configure and be aware of, and you'll have to manage it, and you'll have to, of course, be careful to watch your cost as you scale up. And that's about it when looking at orchestrator or serverless approaches. This isn't terribly detailed, but the main thing you'll need to be aware of for the exam is simply which approach is going to best serve a given scenario, depending on the requirements of that scenario. And the exam will be pretty straightforward in terms of if it's going to say that it needs to run in Kubernetes or if it needs to have as little infrastructure prep as possible, that sort of thing. So just read those questions carefully, and the answer should be pretty obvious to you when the time comes. All right, that'll do it for now. We'll catch you in the next video.